Hello everyone. Welcome back to my channel. Today we are discussed on load acting on the structure. Yesterday we have discussed about the steel structure. Now as we know in structural analysis we are finding the shear force and bending moment for the structural element. So, in structural analysis, we have seen that there is a load that is in UDL form or else in point load form. So, from where that load can be come out, we have to discuss that load how it is acting. Today, let's start. There are two types of load acting on the structure, that is horizontal load and vertical load. What is vertical load? It is also known as gravity load. Means it is weight of the structure which is acting through the gravity of structural element. In gravity load there are three types. First one is dead load, second one is live load, and third one is impact load. In horizontal load also there are two types. First one is wind load and second one is earthquake load. This is the basic load. Other than this load, some more load are acting on the structure, especially for the steel structure, that is erection load, temperature load, accidental load, and secondary effects, means secondary stresses which is acting on the structure. Let's try to understand this all load. So first, in gravity load there is dead load. Dead load is normally self weight of the permanent construction elements. It is self weight of the structural elements like floors, roofs, dividing walls, beam, columns, balconies, lintels, and footing. These are the structural elements which is constructed for the building and it is permanently rest over there, and their self weight is considered as a dead load. For the calculation of this dead load, we should have the unit weight of the elements. For getting the unit weight, we must have IS 875 part 1. In this code, there is a unit weight of all the material which is used in building. Now, what is code? Which are the codes for the civil engineering? These codes are providing us the specific research value for the particular case. Here IS 875 is specially for the loads these codes are specially for the loads. Right? In this IS 875 part 1 is specially for dead load, and in that code we have unit weight of specific construction elements. So we can calculate dead load for this structure like unit weight of RCC is 24 kilonewton per meter cube, means 1 meter by 1 meter by 1 meter concrete cube having weight of that cube is 24 kilonewton, means it is around 2400 kg, means 2.5 ton per meter cube. This load, this unit load of the RCC, and we have the quantity of our element, multiplication of that gives us the load. Also, here discussed about the steel structure, then unit weight of steel structure is 78.5 kilonewton per meter cube. So from the same we can calculate dead load for the steel members and applied on the structure. Number 2, live load. It is also known as imposed load. Live load is acting due to moving elements. Which elements? Moving by time to time on the floor, like weight of person. It can be moved from this place to another place, and the furniture, it is also movable. For the designing of structure, we can take minimum value of this live load from IS 875 part 2. In part 1 there is a dead load, and part 2 is for the live load, means imposed load. This code gives us the value of load for the following classification. Live load or imposed load may be changed with the purpose of the building. First one, residential building. We all aware about the residential building. In residential building, there is a live load is 2 kilonewton per meter square. Live load is always acting on floor, means it is kilonewton per meter square. Number 2, office building. In office there is a furniture and staff as compared to residential building is more. That's why there is 2.5 kilonewton per meter square imposed load. Number 3, banks and reading room, means library and banks. There is a movement of people are more as compared to residential building, and furniture is also there. So there is a 3 kilonewton per meter square. Assembly hall and restaurant, there is also heavy movement of peoples, restaurant as well as in assembly hall. That's why there is 4 kilonewton per meter square. Educational building, there is also student and benches. That's why there is maximum amount of imposed load, that is 4 kilonewton per meter square. And warehouses and factories, means in warehouses and in factories there is a production of something, that production which is stored in particular floor, with the stacking of the bags. For that, there is a maximum imposed load which is up to 5 kilonewton per meter square to 10 kilonewton per meter square. That is depend on the type of structure and type of factories. Number 3, that is most important for the steel structure, is wind load. We know about the wind. Wind load is considered in design of tall buildings. Normally we have seen buildings are 1, 2, 5 up to 10 floor. But in some of the places there is about 50 floors, about 100 floors. For there is a maximum chance of attacking the wind on particular building, that must be calculated for the wind analysis, and this wind analysis is calculated with the help of code. The force exerted by the horizontal component of wind is to be considered in the design of building. It depends upon the value of wind and shape of the building. Both are most important. Value of wind and shape of the structure. It is also depending on the size of the structure. For the calculation of this wind load, we should have all the complete detail for calculating this wind load on structure is given in IS 875 part 3. First part for the dead load, second part for the live load and imposed load, and number 3 for the wind load. Brief idea about this wind load is given below. Let me explain. Depending upon the location of the structure, basic wind speed Vb may be obtained from the appendix A, which is given on the page number 53 on this code. Suppose I am talking about the Ahmedabad, then Vb for the Ahmedabad is 39 meter per second. Now, from this basic speed, we have to calculate design wind speed for particular area, for particular location of the structure. Means we have to calculate Vz, and Vz is equal to Vb into K1 into K2 into K3. This equation is also given in the code IS 875 part 3, where K1 is the risk coefficient. Means if we are going to designing that building, the life of that building, how many years, that we have to first of all decide, and from that we are getting that value of K1 from the code page number 8. Now K2 is the terrain, height and size of the structure. In this factor we are going to calculate particular height of building. Suppose we have height of building that is 50 meter, then in code there is a different height of the building, and for that they have given us the particular factor and size of the building. Means it is a indicate the dimension, and from this dimension we can get the category, and also for finding out the category for the K2 there is a indicate the categories. Number 3, topographical factor. Means suppose our building which is on a plain ground, then theta is 0. If our building is on slopy ground, then there is some inclination of that particular building. So this factor is also calculated from the IS 875 part 3. After getting this wind speed, we have to calculate design wind pressure, and for that we have equation Pz is equal to 0.6 into Vz square, which is also given in the IS 875 part 3. Up to height of 30 meter, the wind pressure is considered to be act uniformly. But beyond this 30 meter, the pressure is increased because up to 30 meter there is a obstruction of the surrounding buildings, but beyond 30 meter there is a little bit obstruction. So acting of this wind pressure is more as compared to 30 meters. Effect of this wind on the structure, which is bending of the steel structure and its member. Due to this wind, our building is deflection in horizontal direction. Number two, blowing of the roof shade, as we know. Failure of the steel tower structure. Fourth, tilting of steel towers. This is also we know about this. Failure of the glass cladding. In today's scenario, there is a cladding of the glass in all the buildings, as you have seen. So, due to that wind, that glass cladding can be broken by the wind pressure. Next is earthquake load. Earthquake causes due to ground shaking. It causes shaking of ground in three directions. Sometimes ground shaking in X direction, sometimes ground shaking in a Z direction, and sometimes ground shaking in upward direction, that is Y direction. For the designing of earthquake resistant structure, there are two methods. First one is seismic coefficient method and the second one is response spectrum method. All the lateral load calculation regarding these two methods is given in the IS 1893-2000. It is also a special code for the earthquake resisting structure design. In this code, there is a criteria for these two methods, as we discussed, seismic coefficient method and for the response spectrum method. We have the calculation, and from that calculation we can calculate the earthquake resistance criteria. Next, snow load. For this snow load, we have criteria. It is given in the IS 875 part 4. Part 1 for the dead load, part 2 for the live load, part 3 for the wind load, and part 4 for the snow load. And remaining other loads, that is called as miscellaneous load. There all the criteria of that miscellaneous load which is given in the IS 875 part 5. Now, for the designing of structure, structure engineer must have to combine this load for the designing of particular elements. There are load combinations given in IS 800-2007. Now, what is IS 800? IS 800 is specific code for the designing of steel structure, which is modified in 2007 recently. For the designing of steel structure, there must be a load combination recommended by IS 800-2007. Load combinations are given below. First, 1.5 dead load plus live load plus 1.05 crane load. In steel structure, there is a warehouses or else factories. So there should be a crane for the lifting of the materials. So we must have to take that crane load in consideration of combination. Number 2, 1.2 dead load plus live load plus 1.05 crane load plus zero point 0.6 wind load or earthquake load. Why I am taking here wind load or earthquake load? Because steel structure is lightweight structure as we discussed earlier, and earthquake is majorly acting on the structure which is having heavy weight. So here the limited chances for acting earthquake on steel structure. That's why here we are taking either or. Number 3, dead load plus live load plus wind load or else earthquake load plus 0.53 crane load. Next, 1.5 dead load plus wind load or else earthquake load. Next, 0.9 dead load plus 1.5 wind load or else earthquake load. 1.2 dead load plus erection load. Here another load is erection load. Now what is erection? So steel structure is made up by members, steel members, and for that lifting of that members we must have used different cranes and jacks. So the additional load for the erection of this structure we have to take erection load as a additional load. Next, 0.9 dead load plus 1.2 erection load and dead load plus 0.35 imposed load plus crane load, and next one is accidental load. Sometimes we are considering this accidental load. It is not every time, but for this sometimes we are considering that if it is happened. So hope you can understand this all the data. Thank you.